Thanks for coming out today. We're going to look at Celery in particular as a task queue in Python. Who can tell me what a task queue is and why it's useful? Anybody? You can be wrong if you want to. That's right. Let me pull up. Oh, you got to be kidding! I got rid of the link I wanted. Let's see here. It's on SlideShare. There we go. So what Alex is saying is essentially, if you think about, let's say a web request comes in. A web request comes in, you process everything that needs to be processed, and you return a response. That's a very typical workflow. Wow, this is really slow. It's a very typical workflow for a lot of different applications. When you think about this even in terms of a CLI or a console application, same thing. You start it up, the program works sequentially, I suppose unless you're Node, but it works sequentially until all of the tasks are done, and then it exits. Well, what if you have a web request? There we go. What if you have a web request that comes in, and let's say that you need to kick off a really long-running process. Let's say you have some computations to do, you need to parse through a file that's been uploaded. Maybe that one web request triggers webhooks to other external locations, and let's say there's 100 of them or 1,000 of them. Does that initial webhook or does that initial incoming HTTP request wait for all 1,000 of those webhooks to all be sent before it can exit and return? So Celery and task queues in general give us the ability to offload work to other processes so that the process that we're currently operating in can return to a different job or can return to the person who called it sooner. There's a whole kind of world of asynchronous programming that we're just kind of tiptoeing in right now. There's things like RPC, remote procedure call. There's things like PubSub. There's things like, maybe some other ones. You got EventLit, and you got gEvent, and you got, I mean, there's tons of different ways to do this. You got async now built into Python itself in Python 3.4 or 3.5. And so there's just different ways of essentially putting work to the side while you do other stuff. And this is Celery and RabbitMQ and this task queue paradigm is just one of those ways. Celery does more than just is more than just a task queue. Task queue is kind of one of the things that it does. That's all we're going to talk about today. It has other kind of modes like RPC and PubSub, and so there are other things that Celery can do, but we're just not going to get into them because we could probably do a semester class on all the things Celery can do, all of its backends, and all of the kind of paradigms and when you would use them. So today we're just going to try to do what I hope is a gentle introduction, although you'll see that once we get into testing, it's not so gentle because there's a lot of stuff going on that you really got to start thinking about. So this design here that I've got up is in essence what we're going to be working on or what we're going to be working with. And so today we're not even going to get to result backend. We're going to kind of not worry about that so much. And instead what we're going to focus on is the fact that you have a front end, you have workers, and then you have this broker that's sitting in the middle and in essence being a message passer in a message queue. When this says front ends, this is not talking about web front ends. What it means is that you have a program that's putting work into the queue. On the back end, your workers are the processes that are taking work out of the queue and actually doing stuff with it. And we'll do examples of that here shortly. The interesting thing, or one of the interesting things about Celery is that you can have different brokers. So Celery can use RabbitMQ, which I should have looked up. What is RabbitMQ technically? It's just a message queue? Okay. So RabbitMQ is a message queue. Redis is in-memory cache that people use for a lot of different things. MongoDB is a key value store. Some of the things that you don't see listed are SQL. You can use a database, either through SQLalchemy or natively, I believe. You can use, well, so I've seen, maybe that's the bulk of it. So you have a lot of different options for what broker you pick. Unless you have reasons to do otherwise, it's probably good to start with RabbitMQ. It's pretty fast. It generally works, and it has resiliency. If RabbitMQ crashes, unless you've done something deliberately to turn that off, your messages will come back when RabbitMQ comes back. Unlike Redis by default, for instance, which if Redis crashes, all of those messages and all that work that you had queued up are just gone by default. And so sometimes you have workloads that is really important to have that redundancy or have that resiliency in your message queue. So, for instance, if I have a situation where I was going to be sending emails to people who've requested password resets, that might be something that's I could go either way with that, right? In some sense, if they don't get the email, they'll probably come back. In another sense, that's a pretty bad user experience for them. So I could maybe go either way, depending upon what my performance needs of the application were. Can you think of something that you're pretty sure you would always want to complete? Document management? What are you thinking about there? Great. So maybe we got an application where people are uploading files to us that we're going to do something with. In order to give them a faster response, we store that file, put a task in a task queue to process it later. That's not something we want to lose. We want to make sure that that file gets processed, even if our message broker dies, even if that server shuts off. Eventually, we want to bring that stuff back and have that processing pick up where it left off. Can you think of something that you may not care about processing at all that you might use Redis for instead? What if you had like a web crawler that was pulling pages, right? So I'd run through a website. Maybe I'm going to crawl that website once a week or once a day. I'm going to pull all those links. I'm going to put those links in a task queue for another process to then process that page. That's probably something that if all that stuff goes away, it's not a big deal because I'm gonna have another run through that website in a day or a week, and if my data is stale, it's probably okay. Now, if I'm scraping stock quotes off of some website, which I shouldn't be doing, but if I was doing that, then of course you want to bring that stuff back as quick as possible. So there's the back end that you use there are lots of considerations for why you might pick one over the other. Something like Redis or RabbitMQ has event notifications, so your code doesn't have to sit there and poll, right, continually checking to see if something's new. If you use one of the database backends, that's exactly what the workers do. They basically sit there and they issue an SQL statement to see if new work has been loaded. When you use RabbitMQ can actually contact the worker and say, hey, I've got more work for you, and it's just kind of sitting there with an open socket waiting for RabbitMQ to tell it it's got work to do. So in that sense, it's lower stress on your, if you had a situation where you had 50 workers and they were constantly pulling the database, that might end up being a non-negligible amount of traffic to have that database just kind of continually sitting there getting hammered by all those workers. Any questions about, in general, the concept of I've got processes I've got applications on one side putting work into a queue, and I've got workers on the other side pulling out that work and working on it. Any questions about that paradigm in general? Okay. Get that off my table until I don't knock it onto my keyboard, right? Okay, so the first thing that I want to do is I want to show you a very basic, really loud. I want to show you a very basic application. I hope most of you are familiar enough with Python to track some of this. If you're not, feel free to let me know or ask questions afterwards. But in essence, what I want to do is I want to start with an application that just works from the command line. So I have a basic Python application that works from the command line, and when I type certain commands, give it certain commands, it's going to run certain code inside the application. And so I want to start with this one. You see that we have a hello command. If I look at the code, I go to my CLI, you guys probably can see that, can you? Better? Okay, so to start with here, I'm using a library called Click, which is a really nice library if you want to do CLI applications. And so in essence, what I'm doing here is I'm decorating one of my functions, and Click is doing all the heavy lifting to essentially turn that into a command that's available on the command line. So I'm not going to get into any of that. You just kind of take my word that I'm not doing anything fancy here. I'm just following Click's documentation to use it. I have given, I do have one argument here, and you'll see that if I do, you'll see that I have this name parameter that needs to be, that can optionally be passed in. And that's what this argument is saying, is I'm going to take a name parameter. If you don't give me it, I'm going to put a default value in there. So my goal here is that somebody would be able to use the command line application. It would have a default value, and if you didn't want the default value, you could pass a different value in. So we'll start with the default. Hello, Celery lovers, which is exactly what I wanted. And if I pass it a name, it will give me a different value. Does that make sense? Everybody comfortable with that? Anybody not comfortable with what we're doing on this part? Okay. So let's go back to my code for just a second, and you'll see that I really don't have much. I don't have much in here. I'm really just calling out to another main function. And so let's go look at this. Oh, that's not what I wanted. Okay, so this tasks file is part of, just so you can see where it is in the tree if you were following along. This code is all posted on, DerbyPy has a GitHub repository, and so there's a project in there called Snacking Celery. If you want to go in there and look at all this code, it's all out there. The test pass continuous integration server set up. So there's if you wanted to have kind of a nice little project to start with, there's a lot of good stuff in this to take a look at. But so I've got a really basic function here. I'm taking the name and I'm creating a string. There's nothing really fancy about it. Now technically, this function, this hello function, is actually a Celery task. And so this Celery task is something that could be run by a Celery worker if I set it up correctly. But the main thing that I wanted to show with this initial example is that because of how Celery works, you don't actually need a lot of that. You don't actually need to use, right? You don't need to use a function, a Celery task, asynchronously. That is, I can use it just as if it was a normal function, and it will work that way, which is what I'm doing here. I'm just calling hello, the value is being passed through. I have to call it a different way if I want if I want to use the asynchronous salary paradigm. So the reason that this is important is because when we start testing, I'm going to talk about how to unit test our salary tasks. And it's important to recognize that a lot of our testing for salary tasks don't have to use Celery at all because the function is just a function. And so I can test it like I would test any other function. And I'm going to show you that here shortly. So let me show you what it looks like to run this task. I'm going to try to do a split screen here. Let me know if this doesn't work. Okay, so one of the things to understand about RabbitMQ is that it creates queues. It creates named queues. And when you put items into the queue, you can see that queue increase in count. And you can know a message has just been added. So the first thing that we're going to do is I'm going to use a RabbitMQ command that comes along with the server, and I'm going to tell it to list the queues that are available on my local RabbitMQ installation. My password is all blanks, by the way. Okay, so I see RabbitMQ has 4 different queues. I've got the default queue, I've got a salary queue, I've got a test queue, and I've got a snacking queue, and they all have different. Except for default, they've got some messages already in there. There's some messages sitting in that queue, and that's just from some of the stuff I was doing before I got here. So to show you that this is actually something that we can manipulate, I have a purge command that I built into the snacking app, and I'm going to tell it to purge the snacking queue. And so now when I run the list queues, you see that snacking has now gone down to 0. And I could do the same thing for celery, tests. The reason that this is important is because as you're experimenting with this, you may run into a situation where as you're going back and forth and you're troubleshooting and you've got workers running and you've got workers stopped, maybe you're trying a command a bunch of times and you can't figure out why it doesn't work, and then you realize your workers aren't running, so you start your workers and all of a sudden they process 10 things, and you're like, where did all that come from? Well, where it came from was the initial commands that you were running were putting stuff into that queue, even though you didn't have workers taking stuff out of it. So as soon as you turned on those workers, you had a whole bunch of work sitting there, and those workers started to process it. So I'm going to show this to you by adding something to our snacking queue. So we have a command called hello tasks. Hello something. Hello task. And so now we see that there's one message sitting in the snacking queue. So now my goal, in order to process that message, is I have to turn on Celery workers. I have to point them at that queue and say, start processing the messages in that queue. So let's do that. There are commands in the root of this project. So this is the command I'm about to run. Dependency management in Python can be somewhat complicated. It involves things like virtual environments, pip for installing dependencies. Usually, there's a new project called pip-end, which is trying to do what NPM does for the Java in the Node world, which is it's trying to, in some sense, hide the concept of virtual environments and just give you a single command that will manage both how your project describes its dependencies and what's actually installed in a current virtual environment. And so I would recommend getting to know pip-end and understanding, reading its documentation and understanding where to use it. I've been starting to use it, and I've found it very helpful. So pip-end run is essentially how I get the dependencies that are specified in this project in a virtual environment. You'll notice up here that I don't have to use pipenv run because I've already used pipenv shell to get myself inside of a virtual environment. So right now, you'll notice that I ran snacking hello task earlier. If I run snacking hello task right now, it says snacking's not found. That's because I'm no longer inside of the Python virtual environment, which is where that snacking command was installed to. But if I want to get back to there, I just have to type pipenv shell. So now that creates a new shell. It gives me a new bash process. That bash process is running with the correct environment variables to drop me inside of a working virtual environment, which is now set up for this project according to the pipenv file, which contains all of the dependency specifications. So if I did pipenv, or I'm sorry, it's pip file, you'll see that I need click and Celery for this project to work. And if I'm working in a development environment, there's some more packages that I want. And pipenv is managing, getting those things, getting them installed into a created virtual environment, and then letting me use that from the command line. Okay, so enough about pipenv, but that's why this command is here. And I have it here because I want to be able to run this Celery command outside of a virtual environment. I don't want to always have to be inside the shell or remember to run pipenv. So that's why I put the pipenv run inside of this shell command. So this is the command, and I'm going to execute that script, which is going to, in essence, just run this. So I could copy and paste this and just paste it on my prompt, and it would work. I'm just not going to do that. Okay, so one of the things, oh, yeah, I was expecting it to run. I'll tell you why it didn't in just a second. So one of the things we want to note is we've got some information here at the top that's helpful. The first thing is that our queue is snacking. This is a custom queue name. By default, Celery will use the Celery queue. It's helpful when you're running projects to make sure that you've specified a queue name, or otherwise, if you've got multiple projects, and let's say you've left some messages from other project that you were just working on, and now you've switched to a new project, and now you start up a bunch of new workers. Well, if they're all using the Celery queue, they start to pull those messages that were from your old app, and that never works, and it kind of blows up, and you might sit there and wonder why for a few hours. So it's just helpful to namespace stuff, and locally, one of the easiest ways to do that, if you're not going to get into the Docker environment, is simply to name your queue something specific to your application. One of the other things that's helpful to note here is that I have concurrency set to 8. That's the default value. I've not done that. It's also pre-fork, which means that when I start this Celery worker process, it's going to spawn 8 other Celery processes that are actually the workers. So total, I've got 9. I've got the one management process, and then I've got the 8 other processes that are actually going to pull from the RabbitMQ queue and do the work. Yeah, so some people like to do their development environment so that it's, in essence, it's all Docker. And so that way, everybody who's working on the project has the exact same development environment. So I don't know, it's not necessarily tied to RabbitMQ or Celery. If you're going to use Docker, you don't really care because you'll have multiple RabbitMQ instances all running at the same time for your specific project, so it doesn't matter what your queue name is, maybe. Unless you've got multiple queues for an app, which is possible. So one of the things you might do is, let's say you had some really important things that needed to happen at a high priority. Let's say sending out your password reset emails. You might have one queue and a set of workers dedicated to that queue for processing email. You might have image recognition that you're doing that needs really high CPU and takes 3.5 minutes per image process. You might have a completely different queue, and even you could have a cluster of servers all pulling from that queue differently. And so there's a lot you can do in the Celery world, in the RabbitMQ world, to kind of separate your workloads based on queue. Celery also and RabbitMQ also support task priority. So even if you wanted to use the same queue, you have the ability to prioritize some tasks and make them float to the top. There's some caveats about that you should probably read about before you use it, because of how your workers do caching of messages. But that's a pretty advanced topic that I'll leave. So in some sense, it wasn't so much that Docker is good or bad. It was just that if you're using Docker, you may not care about what the name is because you're actually running multiple instances of RabbitMQ. Okay, so you have concurrency. So I actually have processes. If I wanted to, I could show you those processes. And so you'll see I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is one of them because I grepped. And so one of these processes is my management process, and the other ones are workers waiting there to do the processing. This always goes so much slower. Like I thought I'd be done by now. Okay. So let's go back down. And I mentioned that I was expecting, when I started the workers, I was expecting those messages that I put in there to be processed. But one of the things that I do is, in this script, I add the purge command, which tells the Celery workers to purge their queue before they actually start. And I do that for the reason that I told you, because I don't like hitting a process and having a bunch of old stuff come up, and I'm kind of like, okay, why did that do it? So if I didn't run this purge command, in fact, let's do that. Let me take purge out of there. We'll close this down. We will load our message in there. We will show that that message has now been added, snacking as 1, and then we will run our workers, and we should see a message. So notice when I run the task, I don't see the output in the process or on the screen where I loaded that message, right? Earlier when I just ran hello, I'm going to see the result in the process that ran that task. The whole point of using the message queue is to do that work somewhere else. And so what I did is I added a message to the queue, and I have another Python process that's part of this whole Celery paradigm that processed that message and ran that hello method with the parameter that we sent it. And so let me show you that I can send it a different parameter. So now it says hello Bill. So I've got a completely different set of processes sitting there waiting for that queue to get work in it. And as soon as I have my front end, when we saw that diagram, it said front end. As soon as those front end processes have work, they insert it into that RabbitMQ queue, and all those workers are just sitting there saying, feed me, feed me, feed me. And as soon as they get something to do, they go, they get it done, and then they come back and they're ready for the next thing. And it's in a completely different process. Now, I'm doing this all on the same machine. You could have racks of machines inserting into message queues and pulling from message queues. So you could have a lot of stuff going on with Celery or some other type of message queue. So if you're in the Amazon world, I want to say it's SMS, but that's not right. SNS? Okay, so SNS is in the Amazon AWS world. They have a whole messaging queue kind of back end, and you can plug into that. Celery, I believe, supports that. Although you don't get some features because SNS doesn't support it. Okay, so any questions? Anybody have questions about how I can add a task here and have it show up on the screen at the bottom? Okay. So let's visualize a little bit what's going on here. There's a tool called Flower that's been built to help you understand kind of what's going on in the task back end, because unlike when I run snacking hello, I get an exception, or I get the feedback immediately. Well, one of the disadvantages to having asynchronous processing is, where does the output go? How do you know if you have an error? How do you troubleshoot if you have an error? So there's different tools and there's different techniques for doing that. But one thing that's helpful is to get a sense of just what's going on, right? Like, what's going on with my Celery workers? What are they actually doing? Are they processing tasks? Are they not processing tasks? Excuse me. Are there errors? So it's easy right now because I just started there on the left-hand screen. I just started my Celery workers, right? It's easy for me if I get an error. In fact, let me do that. I'll show you an error. So notice now I've got a stack trace in my output. So I created a task that deliberately just threw an exception. It's right here. As soon as that task called, it throws an error. And so the Celery process that processed that is not going to die because of the exception. If I was to call that code from my process synchronously, that process would abort. It would die. But Celery's not going to do that. It's going to catch the exception, it's going to report it, and then it's going to go on processing. Because if you had 10,000 things to process and you had 3 exceptions, you don't want all your workers dying because they're hitting errors. You want them to continue processing. But it would be helpful if I have 10,000 things processing to know what tasks are throwing errors. Well, if I had just started it up on my machine, I guess I could output that stuff to a file and kind of, keep track of it and look through it every once in a while. But one of the other things that we could do is use a tool called Flower to keep track of what's going on with those back-end processes. I'm sorry, what? Oh, those are decorators. So I won't go into what decorators are, but you can look those up and learn how to use them. It's in essence wrapping. What it does is it wraps that function in other functionality. Annotations, maybe? Okay. What did I say I was going to do? Oh, Flower. Okay, so I started that process locally. There's a command in the application to start Flower, so you can see how to do that. And I've only got one Celery worker right now. That's not true. I only have one Celery worker manager. I have multiple workers in that Celery process, and I can see that by clicking on it. Oh, yeah. Better? Or you need more? So you can see max concurrency is 8. You can see my process IDs there if you want to. There's other interesting things that you can do. This actually doesn't work. There's some I think there's some permission issues both with RabbitMQ and with Celery to get kind of configured correctly to get the full power of Flower. I just don't care that much, so I didn't take the time to set that up. But if you have workers that you're managing, it makes sense to take the time to set all that stuff up so that you can use Flower to do it. So I'm going to go back to the dashboard here. I'm going to go to processed, and you'll see that it caught that I had this error. And so it tells me the name of the function that was called, the unique identifier which was generated for that specific task. It tells me that it was a failure. I'm going to process a couple other ones here. Let's go back and do a hello task bill, and then I created an add one as well. Okay, so we can see that those tasks got processed. We can see the output here, hello bill. What we can't see is the output from the add. Let's see, received task, tasks.add. So right here, there was the start, and this was the finish. And then you can see the return value here. So unlike, if you go look at my tasks, unlike the hello, which printed and showed up in Celery as output, add returns a value, and shows up at the end of this info log as 5. Now, returning a value from a Celery task is an interesting situation, because the question is, how do you get access to it? The code that calls this is right here, task.add.delay. So if I did result equals, and then I did something like print result, I'm not going to get 5, because it's being processed asynchronously. Instead, I'm going to get that task ID. So if you look down here, we end in 6618B. I have the same task ID here. And so what I'm actually getting back is a Celery result object that has some functionality on it for me to do something with that task. So one of the things I could do is I could turn it into a synchronous call by basically telling that, using that result and saying, wait for this to be done. I could put it in a loop and sleep a half a second and wait for it to be done. So there's a lot of different things I could do. I didn't show you any of those, just because it kind of, then you have to go into things like, what back end are you using? Are you storing the result? And there's a lot of questions there that I don't want to get into at the moment. But just recognize that this process here is exiting before this is done, probably. What is interesting, though, is if you look at the start and stop times, this is really fast. So these two processes both, they're processing within thousands of a second. They're executing those tasks. This is pretty significant when you consider the startup time of a Python process. So let me show you that. If I time this, you'll see that the amount of time that this took was actually, 255 thousandths to run that Python process. So that a lot of that is all of that startup and shutdown and processing the CLI command. And so if you thought about a situation where you had really high need for speed and you still wanted to use Python, and you were in a situation where your process startup time was actually a big part of your delay, you could use something like Celery, where the processes are always running, and all it's going to do, all of your time, is just whatever time it takes to run those commands. So it's really, really fast. Like, you'd think sending something to RabbitMQ, having those workers sit there and wait would be slow. It's not. It's exceptionally fast to make that happen. Okay, so we have Flower doing the task. There's some other things here that you could look at that we're going to skip, but Flower is a nice tool. It's nice to know how to run it, especially when you're developing locally. If you were going to have, a cluster of Celery servers, you're going to have a little bit of work to kind of protect this from, authorization, but it's worth it if you've got a lot of stuff going on and just need to know what's happening. Yeah. Yeah, so you could get some performance monitoring by looking at, if you look at your processes here, you would be able to see things like runtime, and you'd be able to, can you filter here? Yeah, I think you can filter. So, if I wanted to do all the ads, and then I wanted to, I don't know if I could export that. It doesn't look like I've got an export feature. So you could do some of it, but if you were really going to do performance monitoring, you'd probably want to start adding instrumentation or metrics to your code, so that your code itself is putting those metrics out there in some kind of probably third-party service to do metrics, or something like is it Graphene? That's not right. Graph something. Metrics server. There are, but it's not going to be directly tied to Celery. Like, you're just going to have to do kind of general Python performance stuff, and maybe there is some stuff specific to Celery, but I would guess that your metrics is going to be just more Python specific. One of the other things, if you're doing something like this, is Sentry error reporting, or some type of error reporting. And so one of the most difficult things about this is if you get exceptions, how do you know? You know, if I'm processing 1,000 emails a minute, how do I know if some of those failed? How do I know why they failed? Sentry allows you to basically monitor those exceptions and pushes them up to a situation like this where you can, you can see your exceptions and what applications have had exceptions, and you can dig in there and even get variable information. It saves the context that surrounds each of your stack traces. And so it's really helpful if you've got stuff running in production. I'd highly recommend getting Sentry or something like it to do your exception capturing and logging. Logging is another thing, log aggregation to things like Loggly or Logzio or some kind of Elk stack, getting that data in logs so that when something breaks, you can go back and try to get a sense of what were the steps that took to get there, and you actually got that data. Well, you're going to be able to see, like in one sense, I'm going to be able to see that this task was an add task, but it's not going to tell me what front end process I had, or like it's not going to have a process ID or anything. And in some sense, it doesn't. It might matter if the Celery task was failing because the wrong parameters were being sent in. But if the exception is inside the Celery process, more often than not, the bug is actually in that backend code. And so it doesn't matter so much who added the data. It's just that the backend code is not processing the data or the parameters correctly. ERP system, the big issue we had, especially during development, was one team was doing sending the message, they got a process, and kind of two together say you sent that data or you did process right. So it was really key to be able to tie the incoming task with the work or the process to figure out what the problem was. Because if you guys put the message in wrong, or if you got a process wrong, what the work is. Yeah. So I don't think there's anything by default that you could do there necessarily, other than maybe start logging these task IDs. And if you were logging the task IDs, then you'd be able to do some type of correlation. The result backend stores the stack trace. Okay. Okay, so where was I in all that? So I was showing you Flower so that you could see the tasks. The tasks are processing. You get a sense of the number of workers that are there. Okay, any questions about Flower? What we use it for? Okay, so there's so much more with Celery that you can do. Like let's say that you had a situation where you needed to send 1,000 emails, and then once all of the emails were sent, you needed to notify somebody else. But you could only do that notification once all those 1,000 emails were sent. Celery has stuff built in to support workflows like that. So they can do a lot. It's beyond the scope of what I can cover tonight, but there's a lot that you can do with Celery. It can get pretty complicated. When you start doing stuff like that, it can get hard to debug. So as much as possible, try to figure out ways to simplify your workflow rather than use all of the fancy stuff that Celery can give you, because it may work, but it may not. And when it doesn't, you may spend weeks figuring out why it doesn't. Asynchronous programming is just hard. We have a tendency to not think like that. It can be hard. Okay. So what are we going to move to next? I almost said it. Dang it. I gave it away. We're going to move to testing. I love testing. Celery presents some interesting challenges when you start talking about how do you test these things. So let's start with the CLI test. Okay, so I have some code in here to make CLI testing kind of easy. And so if you remember earlier when we called hello from the command line, we got the default response, hello Celery lovers. And so I have some tooling here that makes, from inside the test, makes it easy to call the application just like I would be calling it from a command line. And then I can test the output. So that's what I'm doing here. I'm not really going to go into this because it's not really important for understanding Celery, but just understand that In these two cases, I've essentially done exactly what the code would do if I was calling it from a command line in the test, and then I've been able to assert things about what was in the output to make sure, i.e. that I got the default value that I wanted, and to make sure that when I put a name in right here, I got hello Fred in the output. Does that, anybody have questions about tests or how that might work? So let me show you just what running those tests look like. So I'm going to change directory into my test directory, and I'm going to use PyTest, which I really, really like, and I'm going to tell it to test the CLI commands, and I have 4 that pass. If, for instance, somebody came along and they broke my function, I'm going to get 1 test failure because when I feed it Fred, when I feed my command hello Fred, I don't get hello Fred in my output like I expect because that command's not using it. So I'm going to go back and fix it. And my tests now will pass. Oh, no, they won't. Because I didn't save the file, I guess. I love tests. I love tests. I love continuous integration. I love pushing stuff to GitHub and having somebody like just have my back. Like, let me run those tests for you. That's just so cool. I love it. Okay. So that's fine when we're running things synchronously. What happens when we start to run things asynchronously? What do we do? So you might think, I had to have the right test, otherwise my CI fails, and I don't like that. So I have to comment out the stuff that doesn't work. So in a somewhat naive approach, you can tell up here that when you invoked hello, you got to assert that there was a value in the output. And so you might come down and think, well, I can just do the same thing for my hello task. And if you do that, you're going to get a test failure. Somebody tell me why I'm getting a test failure. Why am I not getting anything in my output? Yeah, because it's, well, and actually at this point, it's not even outputting it anywhere. All it's doing is loading a message in the test queue. And so if we went and looked at, let's stop flower. I guess you need to have that bigger. Okay, so notice now that I've got a message in this queue, and it's sitting there waiting for somebody to process it. If I run my test again, we'll see that it's the test that's adding it. Now I've got 2. So my code, remember, the front end process, all it does is put a message in the queue. Right now, we don't have anything processing from that queue. Why are these workers that are running here on this side, why are they not picking up those messages from the test and processing them? Different namespace. So I talked to you earlier about making sure that that you have different names for different applications. It's also important that your queue name that you use, so how you configure your application, the queue name that you use in development should probably not be the same one that you use when you're testing. Otherwise, what's going to happen is, let's see. So now, when I run my tests, you're actually going to see in the lower left, you're going to see that those workers start to pick those up. Well, I thought you should. Yeah. Git config, snacking. Well, that's interesting. Oh, That's right. You gotta change it. It's actually not there, but I care about changing it. It's right here. There we go. So now you've got workers pulling it off. Now let me tell you, when you start testing and you're running your tests and you got workers running and workers that are running for development purposes are starting to pull stuff out of your test queues, and when we move to what we're going to do later to actually test this stuff, all of a sudden stuff doesn't show up and you're not sure why. It's because you got some other tab open somewhere with a bunch of workers that keep pulling stuff out of your queue. That can be a really frustrating couple of hours to figure out why those tests aren't working the way that you expect them to. So it's really important to set up your application so that you can change the queue name for your test. So right now, what I'm actually not testing. I'm not testing anything. My test is failing. Like, it's failing because my test is assuming I'm going to get output in the current process, and in reality, that's not what's happening at all. Okay, so let's take a step back. Let's undo this before I forget and stand here and try to figure out why the tests aren't working. And let's see. We want to purge the test queue. I should actually have something set up to purge that test queue at the start of the test. I just didn't have time to do that. So now there should be no messages in the test. And comment that out, and I'm going to uncomment stuff that we did. So let's think a little bit high level about what we actually have to do to test this. If I want to unit test hello task, forget that this is here. I was going to do something with that, but I decided not to. If I'm going to unit test hello task, all right, well, first of all, what's the difference? Somebody tell me what the difference is between a unit test and an integration test. That's right. I'm trying to get as small and as narrow as possible in scope. And then an integration test could actually mean a lot of different things depending upon what context you're in. But it's essentially a scale. Integration tests are on the other end. I have more things involved in getting that test to run. And so in my unit test, really, all I want to make sure of for this hello task method when I test the CLI command is I want to make sure that hello task, when it's called, is feeding the name value, the name variable, correctly to hello.delay. That's all I really care about, right? I don't care if Celery works. I don't care if the hello task itself is programmed correctly. As far as the CLI command is concerned, its only job is to correctly hand off the parameter to a different, for our purposes, a different library function, and that's all I care about. I don't care about anything else. So in Python, this is really easy to do, if you consider it easy, with something called mocking. And so that's what I've done here. I'm not really going to get into mocking a whole lot because it can be kind of complicated. But in essence, what mocking is doing when I run this mock.patch, there's actually some code that's, because Python is, everything is an object, it's very dynamic. There's some code that's reaching into this module, because this module in Python is just, it's an object with some variables hanging off of it. And it's replacing, I'm patching CLI.tasks, so it's replacing that variable in that module object with a mock object, which is a really flexible object that does just about anything and will let me assert things about it later. So in essence, what I'm doing is I'm replacing the actual call to the Celery task with a call to an object that will just record what's going on, that I can make assertions about later in the test. So that's what I'm doing here. I mock out the task module. I call the function, or I call the CLI command hello task, and I assert that method, the module, the mock tasks object dot hello dot delay. So I'm basically just following the exact same object structure that the real task has. And then this assert called once with comes from the mock library. That's how I tie into the things that it's recorded. And I'm basically saying, make sure that this dot delay method was called once and only once with the string celery lovers. And if that test passes, then I know that CLI function has done its job. It has called the library function correctly with the parameter, and that's all I really care about. I have another test here doing the exact same thing. All I'm doing now is adding another variable into the CLI command to change the name. And then again, I'm just making sure that delay is called with the string that was passed in. Any questions about this? Okay, so from a unit test perspective of my CLI commands, I don't want Celery to run at all. I don't want messages to be put in the RabbitMQ queues. I just want to mock out this stuff because I don't really care. I just want to make sure that my calling code is using the task correctly, and then I'm going to just kind of forget about it from the perspective of CLI tests. Okay, so if you were in a web context and I had an incoming webhook and that was going to trigger 100 other webhooks, all I have to do is make sure that when I call that webhook and it comes in, that it calls my Celery task correctly and exits. I don't worry about whether those 100 webhooks got created at that point. I'm going to assume, at least from the perspective of this test, from this unit test, I'm going to assume that the library, the Celery task library, is going to do its job and it will be tested elsewhere. Okay. So when I go back now to my tasks, I have a hello task. Now I want a test that tells me if this hello task is called with a name, that the print method is actually called correctly. Because that's what it's its only job, right? Take the input, add it to a string, output it. So if I go to test Celery, I have to do a mock here because the print object is a built-in. I want to get a hold of that print. I want to swap it out with a mock object. I do that with this patch. I call task.hello. Now this is just a direct Python import from snacking.celery import tasks. That's this module. So when I have this hello method right here, there's no mocking going on here. It's this thing. And so all I'm going to do, I'm not even worrying at this stage that this is a Celery task. I don't care. I'm just treating it like a normal function. I just want to make sure that the function does its job. The fact that it gets wired into Celery is something I can test later. So get a hold of my print, assert that it was called once with hello foobar, foobar being the value that I passed in as a variable. Right there. Formatted in the string, make sure the string is formatted correctly, and I'm done. Same thing with the add function. Add, all I'm doing, I'm taking two values, I'm adding them together, and I'm returning that value. I don't need to mock anything here because I'm getting a return value, unlike the previous one, which had a side effect. This function is a pure function. I put input into it, I get something back, so I don't need to mock anything. There's no side effects. I give it 2 and 3. I make sure that the value that comes back to me is 5. Pretty straightforward. Same thing with error. I just want to make sure when I call this method that it raises an error. I use some helpers from PyTest to help me do that in a way that doesn't make the test fail. Okay, so these are my unit tests for my Celery tasks. These are my unit tests for my Celery tasks. I don't care that they're Celery tasks, at least these. All I care about is that they're functions and that they work correctly, and the fact that they're wired into Celery and can be called that way, I don't really care about right here in this set of tests. Any questions about that? Okay, so now we're going to get to something that's a little bit more fun. One of the things that Celery does, which is really helpful, is it gives you the ability to automatically retry tasks under given situations. One of the situations that's very helpful is when you encounter exceptions if you have a task that you want to retry. You could think about this. Webhooks would be great for this, right? I have a network failure. I might want to do an exponential backoff algorithm where, I try it initially every, 0.2 seconds and then 0.4 seconds and 0.8 seconds and then, whatever, an exponential backoff up to 5 minutes, right? So that gives, if I'm trying to send a webhook to somebody, that gives them time for their stuff to square away, their network to stabilize, internet congestion to go away, and I'm still trying to get that webhook to them until it just times out. Anybody else ever use retries like this for something else? What else do you use them for? Okay, just keep trying. Yeah. I have one where we're sending stuff to Salesforce and they have limits on how many APIs or how big data can be. And so I have one where I basically will retry the task and continue chunking my data until I'm done. And so I use retries for that. It's nice that way. If it fails because there's more data or it fails because the API crapped out on me going to Salesforce, it doesn't really matter. I can just keep retrying. I don't really care why I'm retrying. I'm just going to retry until it's done, or I've hit the retry limit, and I want to stop processing. Okay, so let me show you what the retry looks like. So let's talk about what it does. So the first thing that I do is I assert that a random integer between 1 and 10 is 5. I'm deliberately doing that because I want most failures, but within a certain reasonable time limit, I want it to succeed. So I'm instructing Celery to wait 0.25 seconds between retries, and I'm telling it to do 250 retries. I suppose it's possible that we would get all the way to 50 and Celery would actually error out, but it's highly improbable. And so this is a decent way to test this. When that assertion error happens, I log it, I print it, and then I call self.retry, which actually raises an exception. And so this will raise a retry exception. Celery will catch it. So this code only gets ran if the assertion works and the exception is not thrown and retried, and there's no retry happening. So if I do snacking retry, in the bottom left-hand corner, you're going to see multiple iterations of exceptions, and you're going to eventually see a welcome message. There we go. So we only tried 3 times that time. 1, 2, 3, twice. Let me go to the boat. Got good odds today. Okay, so now I've retried, or the retry worked. And run it again. I really need to, yeah. Anybody want the lottery numbers here? Okay. So questions about retrying. How it works, why you'd use it. Okay, so one of the things that makes this interesting now for testing is this method no longer really functions as a standalone. This function, the retry function, no longer really works outside of the Celery ecosystem anymore. Why? Because it needs the retry stuff to work. And even this whole self thing, I'm not even sure that thing's going to be there if you don't call it. I guess it would be there. Self would be there. It would just be a detached Celery task. So how do we test this? Now you could test the happy path here. You couldn't with this. But sometimes, let's say you were doing an API call. You could set up your mocking of your API call so that it always passes, and you could test the happy path. But it's going to be really hard to do the retry, to test the retry. How do you guys do? Do you test your retries? You don't test your retries. We didn't test our retries for a long time because it's hard. In essence, what you have to do is you have to run a worker because it's only inside of the context of that worker that you're going to be able to do a retry. So how do you get there? Okay. So the first thing to understand is that Celery actually comes with tools to do testing. to actually run workers on threads inside your testing process. Normally, we would have our workers operating in different processes. Well, from a testing perspective, that's really not ideal. I really don't want to be spinning up processes and spinning down processes. I could, but if I can get around it, I don't want to. It's going to cause me headaches. I got to serialize data. I guess maybe I wouldn't because it's Celery that I'm using, but it's just a problem. I guess I would, because like configs and stuff would have to go back and forth. And then in those processes, I can't do mocking. I can't do mocks because it's a completely different process space. I can't get a hold of that object. And so what I really want is inside of my process space, I want a little worker running on a thread that's going to do the processing from that queue and return. Thankfully, Celery has that all built in, and they have it built into PyTest fixtures. A PyTest fixture is a way to, in essence, set things up really easily for your tests if you're using PyTest as a runner. So they have something called a Celery session worker, which starts a Celery worker on its own thread, and it will sit there and pull the, well, I guess it won't pull, but it will connect to the RabbitMQ broker that you configure, and it will run any tasks that are ready to be run. And so this gives us a nice way to start a worker and have it run our tasks that we're submitting. There's actually two. You have Celery worker and Celery session worker. Celery session worker will start up once, and it will stay around for all tests. Celery worker will start up and shut down for every test. So just depending upon what you want to use there. Now, we've got another problem, though. And that problem is what? What if, don't pay attention to this stuff right here. If I'm submitting something asynchronously, let's do this. Okay? So this might make sense to me. I've got a task. I'm doing a retry on it. I've got a worker. It's working. I'm going to call the delay, which puts the message in the queue. I'm going to trust that Celery and PyTest have a worker that's running, and it's going to pull from that queue. So I should be able to just wait and get this retry worked command when my retry is done. So let's try that. Expected info to be called once, called 0 times. Why wasn't it called? That's right. My worker was asynchronous and my code kept executing. So in essence, what's happening is I'm not waiting long enough to do this. I'm not waiting long enough to do this. That retry, now sometimes this might actually work. You could actually have a whole bunch of tests that actually work this way, and it works because it just so happens that your worker is actually processing them before your test is making the assertion. I guarantee you that that's a great way to have random test failures, and you're not sure why they're failing. So we could, if we wanted to, we could have some more. Don't do this. I'm just doing it for the sake of argument. So we could do this. We could just kind of wait and see if that works. That worked. Why don't I want to do it this way? I could. It may not work every time, or if I deliberately make my times really, really long, now I've got something that possibly could complete in 0.2 of a second, and now I'm waiting 4, 10, 20 seconds, and my tests now go from running in 5 seconds to 8 hours, and that just really sucks. So what could we do? What could we do here? Thinking about this problem, what could we do to solve this? Anybody? Can you do what? Check the length of the queue. Yeah, I suppose you could sit there and you could poll and just see if the queue has one thing in it. You'd have to make sure before you start the test that there's only one thing in, and then that might get difficult if you've got 3 or 4 tasks that need to run for your test to be complete. But you could do something like that. Anybody else? Could subscribe to the queue. Okay? So that's close. What Celery gives us is events. Celery will notify us, gives us ways to hook in and tell when tasks have been completed. So, what I did is, well, I guess I gotta. So in essence, what I wanted to do is I wanted to hook into every time a task was completed, and I wanted to somehow store that kind of at a global level, and then give me the ability to have something sitting there and looping and essentially waiting for that value to come in. And so to set this up, the first thing you have to do, this conf test file is specifically for PyTest. It's basically where all PyTest will get its configuration information. Excuse me. The Celery PyTest fixtures use the Celery config. So this is, if you just put this in any old conf test, this wouldn't work. It would only work if you had Celery installed and you were using one of the Celery fixtures to get a Celery worker. So I'm configuring Celery, and you'll notice I'm saying task annotations are basically ways to decorate tasks. And one of those annotations that you can use, the star means every task. The type of annotation is after return, so after the task finishes or it returns, I want you to call Celery testing after return handler. So Celery testing after return handler is just a function that gets all of the values. So this is stuff that when Celery calls that event, this is the stuff that's going to be passed through. All I'm doing is turning that into a named tuple, and then I'm adding it to the task tracker using the task return method. So the task tracker is here. Essentially, all it does is keeps a dictionary of the task results, and when you call task returned, it adds that value to the dictionary. So nothing really fancy going on here. I mean, the fancy stuff is that it's kind of happening asynchronously. This task tracker is just a global. It'd be nice to not have a global, not have side effects. I don't know how to do it in this instance, and I don't care enough about pure functional programming to make it figure out how to do it. So I've got a global. Task tracker acts as that. And then the wait for function, when you give it the dotted task, it really just sits there and it loops and it sleeps and it just waits. It keeps checking that dictionary to see if the name of the task that it's waiting for has been done yet. And so it just sits in a tight loop and keeps checking. Again, maybe a way to kind of tie into events. I don't care. This works great. So that's what I'm doing here. I use the task tracker. Note that I do call, this setup will be called before every, part of PyTest is that setup method will be called before every test method on this class is called. And so I want it to be reset. All that reset does is basically clear that dictionary. I want to start from scratch. I don't want to have to be, testing the same task multiple times and I've got something in the dictionary from the last test, right? I'm clearing it out, starting from scratch. And then I tell the task tracker that what I'm waiting for is this task. And that's the dotted name of that task. And I'm waiting for it to be finished. And as soon as it's finished, it's going to return. It's going to give me the result. I'm making sure that that result is a success, that it's not a failure. And then I'm calling with, or then at that point, I can be sure that that log info method was called. And so now through mocking, I can make sure that that method was called with the value that I want to. But I've got to wait. I've got to wait for it to be done. Questions about that? I know that might seem kind of complicated. It was really complicated to figure all that out because the whole PyTest fixtures and stuff wasn't very well documented. I was reading Celery code and then figuring out how to get the right kind of cadence for that testing. How long do you wait and get the events tied back in there? It was, if you look through it now, you can kind of trace it all, but it was like, man, it's kind of, getting through it all and getting it to work was a real pain. One of the things to keep in mind is that you have to set the configuration value twice. This sets it on the worker side. So when I call when I call this retry.delay, it's this value right here that makes sure it goes into the test queue. For the worker, it's this config that controls the queue. I spent like 45 minutes debugging this, like all the way up until I left the office today, because I had this distinction. It wasn't working the way that I thought it should. And it's because I'm actually copying this from some other application setup that we use where I only have to set the config once, and I didn't want to bring all those dependencies in here. So it took a little bit of experimenting to figure out where it was both. But that's why, because one sets it for the worker and one sets it for the front end side that's putting stuff into the queue. So test work. All my tests pass. CI is set up. Code coverage should have been set up, but I don't have the tests generating code coverage accidentally. Questions, comments, concerns?
Do you recommend any options or other external resources for finding out common best practices for these types of stuff?
I don't know anybody. I've kind of come up with the whole testing thing on my own. I think a lot of people punt on testing when it comes to Celery. I mean, you get the unit tests, and you can mock out the callers to make sure they're calling correctly. But I think when it comes to actually doing integration testing, a lot of times it just doesn't happen. But we started doing so much retries that I was like, I just got to make sure that the stuff works in my tests. So no, it's a lot of just kind of piecing that stuff together.
As serialization formats in your brokers, do you use the pickle or do you use JSON?
Yeah, so I think Celery actually switched the default from pickle to JSON in version 4, and so I remember I used to specify it, and now I don't. So I think it's just JSON. Celery in 3 and 4. Mm-hmm. Yep, I remember that. Okay. Really Windows isn't supported anymore? I didn't know that. Okay.
Yeah, I mean, like the change log for it, they review features Microsoft Windows is no longer supported as the tester is passing, and it seems to be working, but then
Okay. I do have a list of resources here in the README of the Snacking Celery repo on the DerbyPy GitHub repo that I thought were helpful as I was kind of going through. If you'd like to look at those. Any other questions, comments?
So in a nutshell, what Celery does let you just decorate a normal method.
Yeah, I mean that's the nice.
Created the backend worker for the method that you decorated in front of you. Celery doesn't really help you front end.
Well, well, Celery it works on both sides because it's the dot delay that serializes that call into the message that gets put into the broker, and it also runs on the back end, and that's how it knows how to take that message and deserialize it and ultimately set up the environment and call the right function. Yep. Now, if you wanted to really dig into the details, I have a link here to the RabbitMQ tutorials. And so the RabbitMQ tutorials have like 6 different levels here. The RPC, different topics, routing, publish, subscribe, work queues, which is what we did in the simple Hello World, and they have Python versions of those. So you could actually just start to kind of build your own queue, and that would give you a good understanding of what Celery is doing under the hood with RabbitMQ, and it would also give you a good understanding of why you'd rather not write all that stuff yourself, right? Celery really is doing a lot, and I think they probably are significantly underfunded. I think they probably end up just like a lot of open source software is, that it's just hard to get funding to do stuff like that, even though a lot of places use them. Yes, there are, and in fact, I gave you a list on the README. Yep. A lot of them have different limitations. A lot of them were Redis only, which I thought was interesting because to me, I like the guarantee of the that RabbitMQ provides for consistency in your queues or recovery of your queues. But this dramatic one actually seems really, really good, but they have an Afro GPL, which means license, which means if you include it in your code, you have to publish all of your source code, even for something like a website or software as a service company. So you do not include that in your code, or you could get fired big time. Did you have a question? So I recommended logging or exceptions. Exceptions was Sentry. Logging was, I mentioned Loggly and Logzio. Logzio is a paid Elk stack. You can set up your own Elk stack if you wanted to. If you Google Elk stack, it's Elasticsearch, Logstash, and Kibana. I've actually done a whole bunch of stuff with logging lately, and I really wanted to use alerting based on logs, like heartbeat alerts, like if I don't receive the log message in 5 minutes alert. And I found that none of those providers can do that because they all have very high ingress delays at times when they get hammered. And so your heartbeat alerts just have constant false positives. So, but if you're just looking to aggregate logs, I actually like the Elk stack better. I think they have the nicest UI. Logzio, for what we're doing, has worked great, except for the alerting. But nobody else did alerting well. So, anything else? Yeah. It is. Yep. But it's really fast. I mean, it's almost, it's just a hair slower than however long it takes to actually run the code. Because RabbitMQ is fast, and that thread sitting there is getting, while this is blocking every time you hit that sleep, it's switching over to that thread. So it's really quick. I do think there's some setup time for kind of running through all the Celery machinery. So if you watch your tests and you start hitting your Celery integration tests, they'll start, the docs will come a lot slower. But I mean, that's why I do as much testing as I can at the unit level, and then I only add integration tests where needed. Anything else? Okay. Thanks for coming. If you have more questions, feel free to come up and we can chat. I'll be around for a little bit longer.